Hello everyone, welcome to our presentation on the image teaching project. Today we will be sharing how we have utilized image processing techniques to create captivating panoramas. In this project, we will explore the significance of image teaching and the key technologies driving our project. Image teaching is essential for seamlessly combining multiple images into panoramic views, offering a broader perspective and enhancing visual storytelling. Our objective is clear: to create seamless panoramas through advanced image processing techniques. We aim to address specific challenges in the stitching process to achieve visually stunning results. There are key technologies used, which are OpenCV, ORB, and homography. We will see in further in methodology. Okay, now as you can see in the slides, there are three input images. Now we have to stitch them and make a panorama image. Okay. Now let's delve into our methodology, which is backbone of our image stitching process. We will explore the key steps involved, such as feature detection, matching, homography calculation, and black edge removal. Our choice of algorithm, including ORB and homography, plays a crucial role in this process. Okay, reorder. First of all, we will reorder the images to ensure the center one becomes the source image and the rest are arranged in alternative to left and right. Right. Then we will iterate to ordered image starting from second image. Now for each pair of these consecutive images, first of all we will use the ORB, which is oriented fast and rotated brief algorithm to detect and compute the key points and descriptors. Now we will use the brute force matcher to find matches between descriptors of the source and destination image. After that, we will select good matches based on distance threshold, and then we will compute homography matrix to transform the image destination image to match the source. So basically, homography matrix what does is that it will match the key points of two images, and then it will transform them into panoramas views using homography algorithm. Now we will wrap the destination image using the homography matrix and combine the source and transform image to create the stitched panorama. Next. Uh, After this image stitching process, we face some issues like black edge occurrence. Uh, the main reason behind this is during the image stitching process, when transforming one image to align with another using the homography matrix, the transformation might result in areas of the image extending beyond the original boundaries. This is the main reasons why black edge occur, and we can remove this by applying median blur, thresholding, and cropping, etc. Now Himanshu will take over after this.
Okay, so here we have two items here, one for image switching and another one for removal of black patches. So let's look at each one. So first of all, we have image switching. So here we have used different Python libraries. So first of all, we use NumPy. So it is used for efficient numerical operation and array manipulation, which are common in image processing. And then we use the OpenCV library. So this library provides powerful tools for computer vision tasks. And in our code, OpenCV is used for image reading, keypoint detection, matching, and variance transformation. Then we use matplotlib. So it is a versatile plotting library. So it's employed here to visualize the images, matches, and transformation at the different stages. Then we use OS, which is the operation system module. It's used to integrate with the file system, so allowing our code to work with the input and output file paths. Then we use TQDM. So this library provides a progress bar, enhancing the user experience by showing the progress of the image processing. Then just use the removal of black edges which we implemented in our next clip. So let's look at how we implement our code. So first of all, we have good constant which is set to 0.9. So this constant is crucial for the quality of the future match. So it sets a threshold to filter out good keypoints during the matching process. By adjusting this value, you can control the straightness of matching and increasing the robustness of the stitching process. So it's very crucial one. Then we have this block of code. So it basically telling first of all we have this file path. So this that variable defines the paths to the input and the output directories, making the code modular and easier adaptable for the different data. Then here we have this row image section. So it's here we basically use the OpenCV time read function. So it's used for the read images from the specific directories. So these images are stored in the raw images. Then we are reordering the images. So the loop is crucial for reordering the images, and it ensures that the center image is selected at the source image, and the subsequent image are arranged alternatively on either side. So this reordering enhances the panoramas quality. And here we are initializing the source image to be the first image of the reordering list. Then we are looking this loop. So the loop through the image starting from the second one, it's index one, and setting the current image as imgdst. This loop is for here we are ensuring that the images are merged from left to right by swapping image source and image dst. Here the index is 1. Then we have this code, this block of code, which is nothing but the ORB feature detector. So here ORB is a remote feature detector and descriptor. It's used to identify key points like key point 1, key point 2, and configure descriptors like descriptor 1, descriptor 2 for the sources and destination image. So these key points are destinating points in the image that can be matched. Then we have this block of code, which is the route for matching and good key point selection. So here we are using this CVBF matches creates function. So this matches computes all possible matches between the descriptor of the key points. Then we are um, sorting the matches which we found. So matches are sorted based on their distances. This is crucial as it helps in selecting the most relevant matches and discarding less reliable ones. Then we have good key point selection. So the loop iterates through the matches and selects good key point based on the threshold set by good points limited. And the steps filter out key points that might introduce error in the stitching process. Then we have this code, which is homography calculation and image transformation. So here this function that we use for homography. So homography is transformation that creates corresponding codes between two images. So like find homography is the another function that calculates this transformation matrix M based on the selected good key points. And this is for the image dimension. So the height and the width of the original image are determined and the maximum values are chosen. So this ensures that the stitch image covers the entire content of the image without losing information. Then we have the matrix form. So this block is for affine transformation. So your affine transformation is applied to the source image, and the affine transformation includes translation, rotation, and scaling. So here it is used to adjust the size of the source image to make the size of the transform destination image. Then we have this transformation. So here we are. Basically, first of all, we are editing the image. So the transformation description image is added to the adjacent source image. So it is the fundamental step in the image stitching process. Then we are determining maximum pixel value. So the maximum pixel value between the adjacent source image destination 1 and the transform destination image are determined. So this helps in creating composite image without losing details from the either images. Then we have this removal of the black edge, which we look at the after some time. So here we are basically post-processing. A custom function remove black edge is applied to remove any black edges that might have appeared during the stitching process. So this step aims to enhance the visual quality of the stitching phenomenon. Then we are updating source image. So the process image becomes the new source image for the next iteration. The iteration process continue until all images are stitched together. Then here we use this matplot setup. So the matplot figure and grid scale are the set of the visualization multiple images in a structure layout. So this figure is tight, like minimize white spaces and has a specific size of better visualization. And these are all the images which we are showing in results. Like multiple subplots are created within the Medford library figure, and each display a different images. So these images include the source image, destination image, matches image, transformed image, and many more. Then here we are saving the image. So the visualized image are saved as the JPG format in the output directory. And here we get the final panorama image. So this is for the image stitching. Now let's look at the removal of the black edge. So first of all, in removal of the black edge, we imported the OpenCV library. And for this function, first of all, we are using median filter. So median filter is applied to the input image. So this filter helps to remove interference that may be present in the black edge of the image. And here this parameter 5 indicates the kernel size, which we can vary according to our requirements. Then we are adjusting the crop effects. So first of all, here we use the threshold function. So the image is threshold to create a binary image. Pixels with intensity value above 15 are set to 255 and others are set to 0. So the steps is essential for identifying the edge of the object in the image. Then we are basically converting it to the grayscale. So here we are converting it to grayscale. So this binary image is converted to grayscale. So this simplifies subsequent operations as the edge information is now represented in a single channel. Then we have this code. This code. This is the function iteration through the binary image to identify coordinates where the pixel value is 25. And the coordinate these 5 pixels are stored in hx and hy. As you can see here, we are storing it in hx and hy. And we have this for the dimensity of cropping image. So the function determines the minimum and maximum coordinates of the identifying edges along both dimensions. Using these coordinates, it's cropped the original image to the removed image. Then we are just returning the image. So the resulting cropped image is returned by the function. And this is just the in the main part of the code. An image is read using OpenCV and the remove bracket function is applied. So the resulting image is the saved as the new panorama.jpg in the output directory. So in the summary, the removal breakage function is designed to eliminate breakage that may appear during the image stitching process. And it utilizes the combination of median filtering, thresholding, coordinate identification of edges, cropping the produced and cleaning version of the input image without unwanted dead region. So this function is applied to the stitch panorama to enhance its visual abilities. And if we just look at the summary of the image stitching code, so this code takes a set of input images, reorders them, detect and matches key points, calculate homography, perform image transformation, adjust sizes, and finally stitch the image together to create panorama view. So and the MATLAB lib is used for visualization and additional steps like post-processing, ensuring a clean and a visual applying result. So this iterative nature of the process, along with the visualization of the intermediate result, allow for fine-tuning and understanding the stitching procedure. So we just basically given three input images. One is this, second one is this, and third one is this. As of now, we are not changing our output directly. So we just run our image stitching function. So let's run it. So it's just working. So you can see it's 50% complete. So how we can able to like show this part? So remember we use the TQDM library. So that library is provides the progress bar. So here how it's so so now it's complete 100%. So let's look at the output directly. And here we have panorama processing one for two images. These are all other images that are under processing. And we have this for second and third images. Here it's and the final image is this panorama image. So you can see it's working completely fine. That's all for the project. Thank you.